All right, now we are going to talk about angle bisectors. Angle bisectors, as we know, bisector means it's going to cut it in half. So if a point, we're reading this here, if a point is on the bisector of an angle, then the point is equidistant from the sides of the angle. So in other words, this ray, we'll call it a ray here, AD, is cutting this angle in half. So these are two equal pieces. And what it means is it's equal distance from the sides of the angle. In other words, this and this are equal. And also what we know are these pieces right here. In other words, AB is congruent to AC because it's this equal distance from the sides is the same distance from the vertex. So it's like, in other words, this distance wouldn't be this, well, I can't do it. I'm not, well, would it be the same? It would be a little bit longer, see, because the angle's bigger there. So the distance that we mark equal distance from the sides from is the same distance from the vertex. So a lot of equals here is what we're seeing. We're seeing these two little angles are equal because it's bisected. We see AB congruent to AC, and then we also see BD congruent to CD. So let's see. If AD bisects AB is perpendicular, and we see these perpendiculars, right? And then what we see is BD congruent to CD. That's what we're saying here. And so the converse is if a point is on the interior of an angle and equal distance from the sides, then the point is on the angle bisector. And so if we have these equal distances and they're perpendicular, it does also mean still that AB and AC are congruent, but more importantly, it bisects the angle. Then the point is on the angle bisector. So we have angle, we'll say angle BAD congruent to angle CAD. So just like with the perpendicular bisectors, a lot of congruencies here. So we can see that it bisects this angle, and so we know that these two have to be same distance from the sides of the angle. So we have 4x plus 30 is equal to 9x minus 5. So we're going to solve these. 30 equals 5x minus 5, add 5. 35 equals 5x. 7 equals x. And that's what we're looking for. We can see these are equal distance, perpendicular, which means these are equal. So 5x minus 11 equals 8x minus 41. Minus 5x. Negative 11 equals 3x minus 41. 30 equals 3x. 10 equals x. Done. Now, similar, we just got 3 more examples. Similar, but now we have to find AD. So we're going to set those equal to each other. We can see that it is bisecting that angle and perpendicular. So 13x minus 4 is equal to 8x plus 11. And solving 5x minus 4 equals 11. 5x equals 15. X equals 3. But remember, we need to find AD. So I'm going to switch colors here. We're going to have AD is equal to 13 times 3 minus 4. So I'm going to use my calculator. 13 times 3 minus 4. Looks like 35 is our answer. And let's see, for this one, XWZ. So we're looking for this one right here. And we know that these are equal. So we have 8x minus 32 equals 3x plus 3. So minus 3x from both sides. We get 5x minus 32 equals 3 plus 32. 5x equals 35. X equals 7. But we want that little angle. So we're going to plug back in. Angle XWZ is equal to 8 times 7 minus 32. I'm going to use my calculator. 8 times 7, 56 minus, 32. Looks like it's 24 is the answer. And finally, FGH. Oh, we want to figure out this whole thing. We need to figure out the whole thing. But we know that these two are equal to each other because it's on the angle bisectors. So 2x plus 20 is equal to 5x minus 37. 20 equals 3x minus 37. 57 equals 3x. X equals 19. So let's see. Let's plug back into one of these. So 2 times 19 plus 20. So 2 times 19, 38, plus 20, 58. So this is 58, which means this is 58. And so angle FGH is equal to 2 times 58, or 116 degrees. All right, and that is it for angle bisectors. Lots of congruencies.